Hello friends, I'm glad to have you back in my second video of the series on solving aptitude questions on boards and streams. I have discussed the basic concepts and tricks in my first video. I have given the link to this video in my description box. Don't forget to share my video and subscribe to my channel for more easy tricks. I will be discussing tricks as I solve each question, so watch my video till the end. Let's begin. The first question says, a man's speed with the current is 15 km per hour and the speed of the current is 2.5 km per hour. Then what is the man's speed against the current? We are given that the speed of the man with the current, that is the downstream speed, is 15 km per hour. Also it is given that the speed of the current is 2.5 km per hour. I have already discussed this in part 1 of this video series, that we denote the speed of the boat in still water as x and the speed of the current as y. We need to find the upstream speed in this question, and let us take a quick look at the trick to be used to solve this question. It says that if the downstream speed is x plus y and upstream speed is denoted by x minus y, where x is speed of boat in still water and y is the speed of current. X plus y is 15, where y is 2.5 km per hour. From this we get x as 12.5, and substituting the value of x as 12.5 and y as 2.5 in the formula of upstream speed, which is x minus y, we get upstream speed as 10 km per hour. This gives us the answer. Let us go to the second question. A man can row upstream at 7 km per hour and downstream at 10 km per hour. Then what is the man's rate in still water and the rate of current? Here we need to find the values of x and y given the upstream speed and the downstream speed. If we denote A as the downstream speed, then we are given that A is 10 km per hour and B, which is the upstream speed, is 7 km per hour. The trick is that given A and B, the speed of boat in still water is A plus B by 2, whereas the speed of current is A minus B by 2. Substituting the values of A and B, we get the speed of boat in still water as 7 plus 10 by 2, that is 8.5 km per hour, and the speed of stream as A minus B by 2, that is 10 minus 7 upon 2, which is 1.5 km per hour. Now comes the next question. A man can row 18 km per hour in still water. It takes him thrice as long to row up as to row down the river. Then what is the rate of the stream? That is, we are given the speed of man in still water, that is the speed at which he can row the boat. This quantity is denoted as x, and we need to find out the value of y, that is the rate of the stream. Given x is equal to 18 km per hour and y needs to be found out, we use the formula x is equal to y n plus 1 upon n minus 1, where it says that if it takes n times long to row upstream as to row downstream, then this formula holds true. In the question, we are given the value of n as 3. Substituting the value of x and n, we get x is equal to 2y, or y is x by 2. X is 18, hence y will be 18 by 2, that is 9 km per hour. Taking up the next question. In a stream running at 2 km per hour, a motorboat goes 6 km upstream and back again to starting point in 33 minutes. Find the speed of motorboat in still water. Here we are given the rate of stream is 2 km per hour, that is we are given the value of y. It says that if the starting point of a motorboat is A, then the motorboat goes from A to a point B, which is 6 kilometers apart from A upstream, and the motorboat comes back from B to A in 33 minutes. That is, the two-way journey takes 33 minutes, which is 11 by 20 hours. If we look at the trick to solve the question, it says that if it takes t hours to row a place and come back, then the one-way distance between the two places is given as d is equal to t into x plus y, x minus y upon 2x. Please note that there can be a confusion when you solve this question whether to take d as 6 or 12. It is very clear that here we need to consider d as one-way distance even though the motorboat is travelling to and fro from A to B and back to A. So taking the value of d as 6, t as 11 by 20 and y as 2, we get the quadratic equation 11x square minus 240x minus 4 equal to 0. If we factorize this equation, we get the two factors as x minus 22 and 11x plus 2. We discard 11x plus 2 because when 11x plus 2 is equal to 0, we get the value of x as negative. So retaining x minus 22 equal to 0, we get x is equal to 22 km per hour. This solves the question in an easy way. Let's move ahead. A man can row a boat to a certain distance upstream in 4 hours, and it takes 3 hours to row downstream the same distance. Then what is the speed of boat in still water if the speed of the stream is 2 km per hour? If you carefully look at the question, we need to find out the value of x, that is the speed of boat in still water, when the value of y, that is the speed of the stream, 2 km per hour is given. It also says that the time to cover upstream is 4 hours, whereas to cover the same distance downstream it takes 3 hours. We say that T1 is 3 hours and T2 is 4 hours. Using the formula that if it takes T1 hours to row downstream and T2 hours to row upstream, we get x is equal to y, T2 plus T1 upon T2 minus T1. For those of you who are wondering as to how this trick has suddenly come, I have already discussed it in part 1 of my video. You can find its link in the description box. Substituting the values, we get x is equal to 14 km per hour. You can find for yourself that using such tricks save a lot of time, which is very important in any competitive exam. So what are we waiting for?